Example 2, solving a right triangle. So again, what I'm going to do is start by drawing a picture of it. I think you want to do this. I know a lot of times people want to be lazy and not draw a picture, but I really think it helps. Angles are capital letters. Sides are lowercase letters. Hypotenuse is C, so that means the right angle is C. Okay, so I'm going to label what they give me. They give me side A is 29.43 centimeters, and side C is 53.58 centimeters. In general, whatever they give you two of, it's almost always easier to find the third one. So I see two sides. I should be able to do Pythagorean theorem there for the third. Okay, so a squared plus b squared equals c squared. We can do 29.43 squared plus b squared equals 53.58 squared. Straight Pythagorean theorem. All right, so subtract this over. I'm going to kind of skip over something real quick. You're going to subtract that over, and what was it? 53.58 squared minus 29.43 squared, 2004.6915. You're going to have b squared equals 2004.6915. Notice what I did. I subtracted this over. And then we're going to need to square root that. So square root of that number gives me about 44.77. So B is 44.77 centimeters. All right, 44.77. I've got all the sides. I've got one of the angles. I've got to find the other two angles. Okay, now that's where trig comes in, because trig is going to be a good link between sides and angles. So pick one of the angles. I'm going to look at angle A first. Okay, so I would try to use the numbers that you were given in the problem, just in case I rounded off on my 44.77. Okay, if anything went wrong with 44.77, then everything after that is wrong. So I'm gonna try to use the green ones, 29.43 and 53.58. So if you notice, here's your angle. That's opposite, and that's hypotenuse. Sine is opposite over hypotenuse. So if I want to find angle A, I can say sine A equals opposite over hypotenuse. Now, this one's a little bit different than the last problem because you're missing the angle. Okay, so I always relate it back to a problem like this. If you're solving an equation with only one variable, you always undo those operations, right? Don't write this down. And you're going to subtract 4 and you're going to divide by 2. You're undoing operations, right? Okay, that's how you solve. And so it's the same thing with this problem. We're going to undo the math that's on the angle. We're going to undo a sine. And what's going to undo a sine? Inverse sine. This is not multiplication. We are not multiplying both sides. We are taking the inverse sine of both sides. So angle A is going to equal inverse sine of whatever that is, to 29.43 divided by 53.58. And you can divide that out if you want, but I'm just going to plug it all in. We're going to do an inverse sine of 29.43 divided by 53.58. Inverse sine of that gives me 33.32. A equals 33.32 degrees. I'm going to go ahead and write that in, 33.32 degrees. Now I've got everything except for that last angle. Okay, that last angle right here is B, but that should be easy to find if we've got two angles, because we still know that property that angles in a triangle are going to add up to 180. So this is probably the easiest way of doing it. 180 minus 90 minus 33.32. But it's not the only way of doing it. You could do SOHCAHTOA again if you want. Do a different trig function or a different angle or whatever. But I would try to find the easiest way. 180 minus 90 minus 33.32, 56.68. B equals 56.68 degrees. Solving the triangle means find all the missing parts. I've got them, so I'm finished.